Hello everyone, my name is Alexander Shapkin and I work as a software engineer at GridGain system. And today I would like to talk about GridGain Operator, and we will see why would you ever need a GridGain Operator and what tasks could be solved with it. So the first question that we need to answer is why do we even might need a Kubernetes operator? So we need to understand that modern applications are quite complex, and for example, a database application or Apache Ignite or GridGain cluster does require, some special knowledge from a user who's operating that software, and especially if we are working on a Kubernetes cluster. So once again, a person needs to know how to perform some general routines like rolling restart, how to provide configuration updates to your cluster, how to upgrade it to new version, and so on. And for that, the user needs to understand the internals of your applications. I mean, how to manage a stateful set, in which order the pods should be restarted, how to provide a persistent volume to your stateful set, and so on. And it seems like should be some automation tool that could help you to, to automate that routines, and it's basically is an operator. And I think now we would like to, to discuss how to build an operator. And obviously, there are different ways of building an operator, and most common one is so-called operator pattern. And this pattern actually consists of two major parts. So first part is so-called custom resources or CRs, and a user creates them and adjusts them uh, in order to describe the desired state of your cluster. So for example, a CR could have a definition, the following definitions. A user might set that it would like to have a cluster with two nodes, and it should use it should use Apache Ignite image, and a user might want to deploy a persistent cluster rather than pure memory one, and so on. And operator pattern, on the other hand, does have an operator deployment. So this operator deployment is a regular Kubernetes, deployment that will run usually a single pod, and this pod will contain all domain-specific knowledge and knows how to react to the changes in your custom resources. So, for example, uh, when a user needs to adjust a current state of a cluster by providing, a new value for nodes count, say instead of 2, a user might wants to run 3 nodes. He just changes a CR resource, and the operator detects the changes and applies the specific routine in order to make current state to the desired one that was provided by a user through this custom resource. And also, I'd like to mention that operator pattern doesn't bring like anything new to the Kubernetes. It instead just leverages existing APIs and extends them with the notion of custom resources. And these custom resources are being created with so-called CRDs or customer resource definition files, and these files just describes the structure of your customer resource. So a CRD would have the following definition that okay, a user might want to create the following customer resource with the following structure. The customer resource might have a number of nodes parameter, and it's going to be an integer field. Also, a customer resource might have image field with type of string and so on. So let's move to GridGain operator and check what it can afford for us. And first of all, it's totally free, so you might easily just download it from the official website and run inside your Kubernetes cluster. It was solely designed for managing GridGain or Apache Ignite cluster, and it does support most popular cloud providers, and it was built using the operator pattern, and it provides you with a declarative pattern configuration. So you will adjust your customer resources in order to say what state is a desired one, and GridGain operator will adjust current state and make it to the desired one. So let's move to the next slide and talk a little bit about GridGain operator internals. And you can see that this picture is quite similar to the operator pattern schema. So here we have once again a notion of customer sources. There are two CRs actually, Ignite and Ignite config, and there is a operator deployment that's tracking for changes in Ignite or Ignite config CRs and applies the required routines in order to adjust the current state of your cluster. So for example, imagine that at the moment there are no CRs deployed yet, and there is only an operator deployment running. When a user creates an Ignite or Ignite config resources with the desired state, operator detects these changes, that okay, previously there were no customer sources, now they exist, and okay, I need to create a new cluster with a specific configuration in these customer sources. And GridGain operator knows how to deal with Kubernetes objects like stateful set, how to configure the config map, or how to provide a persistent volumes for your persistent clusters, and so on. Okay, now I would like to talk a little bit in detail about Ignite resource. So this resource was solely designed for providing a high-level settings for your cluster. So we can see that it does have namespace parameter to which your cluster would be deployed. It does has a cluster name. It also might, a user might say how many nodes should your cluster have, whether it should be a persistent cluster or in memory. You can set an image to which operator should you use in order to build your cluster, and so on. The other resource, customer resource, is Ignite config, and basically it is, it acts as a wrapper for Ignite config XML file that you most likely will create and adjust in a non-Kubernetes word. And so here you might see a snippet of this customer source, and basically you can see that there is only a single parameter within conf that contains a string representation of your Ignite config XML file. And here you might also notice two placeholders for namespace and cluster names arguments, and these values, these placeholders would be replaced by GridGain operator automatically from the values that was previously set in Ignite resource. Okay, so we've seen and understand from which part the GridGain operator is built and what customer sources needs to be configured in order to provide GridGain operator with the desired state of your cluster. So now I think we can move towards our demo. Okay, and I assume that you have a Kubernetes cluster configured somewhere. You might want to choose, one of the supported environments. I will use a local one. Also, you need to have a kubectl utility configured, and I assume that you downloaded GridGain Operator bundle from the official website. And this bundle contains, in this bundle you might find a set of different YAML files that our operator needs to deploy in order to, to operate on your cluster. Okay, so here I would like to, use Visual Studio as my text editor with Kubernetes extension installed. And I have already downloaded GridGain bundle that consists of YAML files, and there is a folder for your custom resource and custom resource definitions called CRDs. And also you might notice operator, role binding, and service account YAML files that represents our GridGain operator. And there is also one file called default Ignite operator, and this file is an aggregation of all other files. So you can, instead of running multiple commands of deploying different types of resources, you might want to do it just in one place with default Ignite operator YAML file. Okay, so now let's check what do we have inside my Kubernetes cluster. We can see that nothing special. And I would like to, in order to start, I would like to create a dedicated namespace to which I will deploy my GridGain operator. So let's do it. And I would like to deploy CRDs files to newly created namespace. And I need to deploy other files like operator deployment and permissions for the operator. And as I said previously, I will use default Ignite operator YAML file, and I need to specify the correct namespace to which my resources needs to be deployed. Okay, now we can see that all requirements are satisfied, and let's see what is happening to the cluster. For that, I will use Kubernetes extension, and yeah, we can see, as we can see, our GridGain operator understands that what we want, and basically we wanted to have a cluster, GridGain cluster, with the default settings that was provided for us in default Ignite operator YAML. And I expect that GridGain operator will create a cluster with 2 nodes. Yes, as we can see, now we have 2 nodes, basically 2 pods running in our cluster, and it's cool because it is what we were expected. So now let's check, the logs from one of the pods, and we might notice that our cluster is actually a GridGain version 8730, and we have 2 servers in our cluster. That's fine. And so the next step that I would like to do is to find a link to GridGain Control Center, and I can do this. Well, actually, you can see this link, and yeah, I would like to highlight that operator already performs all required configuration in order to connect your GridGain cluster to the hosted version of GridGain Control Center. So you don't need to adjust anything. You can just follow the link. So let's copy it and open in our browser. So if you don't know what GridGain Control Center is, it is a tool for managing your GridGain or Apache Ignite clusters, and it has a rich, user interfaces and nice charts. You can do some stuff with it, like performing some SQL queries. You can perform some cluster routines, like you can activate cluster, deactivate it, and so on. You can track your balance progress, and yeah, basically it's better if you refer to the official documentation about GridGain Control Center. And here we can see that our cluster is successfully connected, and there are 2 nodes in our cluster. So the next step I would like to do, I would like to adjust my the desired configuration of my cluster using using Ignite customer source, and I would like to change number of nodes from 2 to say 4. Yes, in order to to provide a new state to the operator, I need to save this file, Ignite customer source, and apply it to the Kubernetes cluster with the following command. Okay, so our new customer source, our new desired state was provided to the operator. Let's see what is happening to the cluster. think I'll use the following command for tracking the pods. And we can notice that new pods are running and was scheduled by the operator. Let's update Kubernetes extension. We can see that now we have 4 nodes actually. Let's check what's inside our GridGain control center. And it also detects that new nodes were added to our cluster. So the next step here, I would like just to show how easy is it to run some, SQL queries. For that, you need to go to the SQL tab, and you need to just execute your, SQL query. But yes, since we are running a persistent cluster, it needs to be activated before we can actually do any processing. So for that, I will follow this and I will activate cluster using, user interface. Okay, so now our cluster is active, and I believe we are good for running the query. Yes, as you can see, our query was executed successfully. Okay, and in order to remove our cluster, we need to set the following, the following parameter state to be absent, and I just uncommented that. Please note that this, this logic was reworked recently, and in the newer versions of GridGain Operator, you won't adjust the state parameter, and instead you will trigger the termination logic by removing the customer source, Ignite customer source, and operator will detect that your customer source has gone and will trigger this deletion procedure. But right now I will do this by modifying state. So we need once again to save this file, and we need to run the following command. Okay, now we can see that our resource is configured. Let's check what is happening to the cluster. Right now, all pods are in red, meaning that GridGain Operator needs to remove them, and yes, now they are gone. So it is correct behavior. And the next step I would like to do, as I said previously, is to deploy Apache Ignite version of our cluster. I will say that, okay, I need 2 nodes, and I would like to say that I want to deploy this cluster to another namespace, say it Apache Ignite test v2, and I need to change cluster image parameter to Apache Ignite 290, and I don't want to, to have my cluster terminated, and I need to comment the state. So once again, I need to save the file and apply kubectl command. Okay, our new version of our customer source was just configured. Let's check what is happening to the cluster. So we can see that there is a new namespace, Apache Ignite Test v2, as we declared in our customer source. Okay, we have one port in green. So let's inspect the logs. And we can notice that it is currently running Apache Ignite 2.9.0 version. Once again, update that. Okay, now we have 2 pods. The number of pods is correct. And we can notice that there are 2 servers running as expected. So the next step I would like to do is to manually activate our cluster. For that, I need to connect to one of the pods. I will use it through the Kubernetes extension. And we need to go to the following directory. Here should be a control script, and we can run it and check current state of our cluster. Cluster is inactive, so let's activate it. And we can see that our cluster is active finally. So that's how you might, adjust your cluster manually. I'll exit from the terminal. And the next step I would like to do is to adjust current, internal configuration and adjust Ignite config custom resource. For that, I would like to uncomment the new cache definition, and I expect that operator will forward these changes to the cluster, and a new cache with the name new cache will be created. So let's save that file, run kubectl apply command, but we need to apply a different file. And now we can see that our customer source was successfully configured. And let's check what is happening to the cluster. We can see that GridGain Operator successfully understands that new version of internal configuration comes and it needs to restart the pods in order to apply this new configuration. Okay, so I think I will, connect to one of the pods once again, and I would like to inspect Apache Ignite logs in the terminal. So for that, I need to go to the following directory, and we can see that there are log files that were written by Apache Ignite. So let's check. Actually, let me just copy paste that. Okay, now we can see that inside our logs there is a message that basically says that new cache with name new cache was successfully created, and basically it means that our new configuration was successfully provided to our cluster. Also, I would like to highlight that you might inspect current version of the cluster in the config map resource. Here it is. Now I think we can move back to our presentation. So what else does GridGain Operator support? Well, it supports a configuration for private repositories if you would like to, if you need to adjust or configure the private repositories, you might do this with GridGain Operator. Also, you can configure readiness or liveness hooks for your images if the defaults are not what you were looking for. And obviously there are some special routines such as rolling upgrade, for example, and these routines applies only for GridGain editions, because naturally Apache Ignite just doesn't have these features, and that's why you can't run it with Apache Ignite. And you might refer to the official documentation for checking other features of GridGain Operator. Okay, what's next? Well, we have several plans for our operator, and in the near future we are thinking about enhancing our distribution model. We are thinking about providing a Helm chart or using the operator lifecycle manager, and it will simplify the distribution and usage of GridGain Operator. The next step we would like to probably do is to we would like to integrate our GridGain control center deployment to our operator, and probably you will be able to run and deploy on-premise version of control center near to your cluster automatically by the operator. Also, we would like to work on security configuration that your cluster might need, obviously, and we are thinking about supporting, different availability zones. In other words, the operator will allow you to provide a configuration that says about, that basically I need part of my pods being deployed in one availability zone and other pods need to go to the other one. So this could be nice for a disaster recovery plans and so on. And ultimately, we would like to have our operator running in a fully autopilot mode, meaning that it can react to some alerts or triggers and understand what actions needs to be done right now in order to ensure the stability and health and how healthy our cluster is at the moment. And operator might scale a cluster dynamically, vertically, or horizontally, depending on some conditions. It might help you to recover from some failures and so on. And all these tasks should be done without any human interruptions. So it will be nice to have really this mod. And in summary, I would like to highlight that GridGain Operator does provide a declarative way of specifying the desired state of your cluster. It does reduce deployment time and maintenance as well. since it automates most routines. It avoids maintenance errors and allows you to switch your focus from the configuration routines to the development. And we have more features to be released, so stay tuned. Here are some links that you might want to follow in order to read more about operator, about thanks for joining the webinar. Thanks. And if you have any questions, please ask them. I can see that there are a couple of questions about this theme. And first one is how are the operator's capabilities different between Ignite and GridGain? And to answer that questions, I would like to say that first of all, you can definitely deploy both editions with GridGain Operator. You don't need, two operators. It's fine to have GridGain only. GridGain Operator. Though, yeah, as I said previously, some features are just, some features were designed specially for GridGain and especially for GridGain Enterprise or Ultimate editions. And since that, you can perform them for your Apache Ignite cluster. And the obvious example would be rolling upgrades. Ignite don't support them, and GridGain does. The next question is, can I put the operator's version manually while configuring it? Well, yeah, sure, definitely you should do this, and for that you might want to adjust operator YAML config file. Basically, it is just regular Kubernetes deployment with one replica. And here you might see the containers definitions and image parameter. Here by default Apache Ignite operator latest is set, but you can manually adjust the tag with your specific version like this, and just save file and deploy it to the Kubernetes with kubectl apply command, and it should run your specific GridGain operator version. So, and I think there is one more question. Can you comment on the recent updates to GridGain clients that can help in Kubernetes environments? Well, I might not be aware of full updates that happen to the clients, but I believe that it's about configuring the discovery IPA, and I suppose that with the new updates, I think client will be able to to configure the TCP discovery Kubernetes IP finder, or some analog of that, and with that new IP finder, I think client will be able to connect to cluster automatically, because right now I believe you need to specify static values if you are using static discovery SPI, or alternatively you might want to configure a Kubernetes service and use it as a entry point for your thin client. But it's better to address the official documentation or about the details, because I might be missing something. Okay, seems like we don't have any other questions. and I think we are good now. Thanks everyone for joining the webinar.